Hi everyone, so this is the chapter 10 multiple choice section. As always, if you have any questions, please let me know and I will gladly walk through any additional details or anything that you want. So the first one says, which of the following specifications could not be employed for estimating a short run production function? And our answer is D, and this is just straight from the slides. So if you go read the slides from the book, this question is answered. Next one says, which of the following represents a short run cubic production function? And our answer is C. And again, this is just in the slides. And for the sake of time, so that this video doesn't run too long, I'm not going to go into too much more detail if it's already defined in the slides. Next one says, with a cubic production function of the form Q equals A cubed L cubed plus B K squared L squared, in order for the average and marginal product functions to have their usual theoretical properties, it must be the case that A is less than 0 and B is greater than 0, and this is also in the slides. But these are required in order for our functions to look the way that we expect them to look. 7 says, when estimating a short-run production function of the form Q equals AL cubed plus BL squared, it is necessary to specify in the computer routine that the intercept term is forced to equal 0. A and B will be defined this way, as we said in question 6. It will be defined this way naturally if we're using correct information to feed the computer. So this should be the information that the computer provides. Question 8 says an average variable cost function is estimated by 96 minus 2q plus 0.05q squared. This means that our A, as defined in the chapter, is 96, our B is -2, and our C is 0.05, which means our short run marginal cost is defined as A plus 2BQ plus 3CQ squared. And if we substitute in those numbers, we're going to get 96 minus 4Q plus 0.15Q squared. And then our total variable cost is average variable cost times Q. And we have our average variable cost up here. So we're going to have 96 minus 2Q plus 0.05Q squared times Q. So 96Q minus 2Q squared plus 0.05Q to the third. And if we look at our answer choices, our short run marginal cost is the same as D, and our total variable cost that we found here is the same as B, giving us the answer of E, where both B and D are correct. Question 9 says a short run production function was estimated as Q equals -0.002 L to the third plus 0.16 L squared. At what level of labor usage does the maximum average product of labor occur? So our average product is Q divided by L, which is going to be -0.002 L to the second plus 0.16 L. And then we're using this, and we're going to take the number that's in front of our L without any exponents, so it's going to be 0.16. over 2 times the coefficient in front of our L squared, so 0.002. And this is negative, and the formula requires a negative in front, which gives us 40, which is C. The maximum average product is occurring when, or we're asking ourselves, when does diminishing returns start? Question 10 says, what is the total product when average product is at its maximum level? So this is actually the same basic as we just did for question 9. So we already know that we're using 40 units of labor. And that's from question 9. And then we're going to substitute that 40 in for L. So we're going to have Q equals 0.002 40 to the third plus 0.16 40 squared. And when you type that into your calculator, you get 128. Question 11 says, at 20 units of labor, what is the average product? So to find this, we first need to find our average product function. So our average product function is Q over L, or Q divided by L, which is essentially just going to reduce each of those exponents on our L by 1. So we're going to have negative 0.002 L squared plus 0.16 L. And then we're going to substitute in a 20 everywhere we see the L. So negative 0.002 times 20 squared plus 0.16 times 20 gives us 2.4. And you can also substitute 20 in to this original equation and then divide by 20, you'll get the same answer. So if you prefer to do it that way, if that way makes more sense for you, that's okay, that's fine. Question 12 says a short-run production function was estimated as the same thing we've been using. At 60 units of labor, what is marginal product? So our marginal product, if we look at this quantity, is going to be negative 0.006 L squared plus 0.32 L. And this is coming from either using the marginal product equals the derivative of Q with respect to L, or you can use your formulas that are given in within the chapter and plug them in. You'll get the same thing. And then with that, we're going to plug in 60 everywhere we see an L. So our marginal product at 60 is going to be negative 0.006 times 60 squared plus 0.32 times 60. So our marginal product at 60 gives us negative 2.4, which is E. Next one's just a definition question, and it says the opportunity cost of capital owned by the firm should reflect, and our answer is the return foregone by using the capital rather than renting it to another firm. Opportunity costs are taking into account what should have been or what could have been if we used these resources in another way. Next one, it gives us a regression output. And we are going to use this regression output. So first, we are going to find that our average variable cost is equal to 43.4 minus 2.8 Q plus 0.20 Q squared. And these numbers are just coming from right here. So our 0.2 is coming here. Negative 0.28 is going here. And then finally, sorry about that. And then finally our 43.4 is going here, which means our A is equal to 43.4. Our B is equal to negative 2.8. And our C is equal to 0.2. So we're going to use our short run marginal cost. If you use your formula, you have A plus 2BQ plus 3CQ squared. So we substitute that in, and we get short run marginal cost equals 43.4 minus 5.60 times Q plus 0.6 Q squared, which gives us an answer of D. 15 says, at what level of output is average variable cost at its minimum point? So we're going to use our average variable cost formula that we found on the previous question, which was 43.4 minus 2.8 Q plus 0.20 Q squared. And then we're going to use the formula negative B over 2C, which is negative 2.8 divided by 2 times 0.2, which is a positive 2.8 times 0.4, which gives us 7. At what value does average variable cost reach its minimum value at? So we just found out that our quantity was equal to 7 from question 15. So we're going to substitute 7 into our average variable cost function. So our average variable cost function is 43.4 minus 2.8 Q plus 0.2 times Q squared. So if we substitute 7 into that, it's going to be 43.4 minus 2.8 times 7 plus 0.2 times 7 squared, which gives us 33.60, or B. 17 says if they produce 20 units of output, what is our estimated average total cost? So we know that our average variable cost is given by 43.4 minus 2.8 Q plus 0.2 Q squared. So we're going to substitute 20 into that so we can get our average variable cost at 20, which is going to be 43.4 minus 2.8 times 20 plus 0.2 times 20 squared, which gives us 67.4. And we want average total cost, which is average variable cost plus average fixed costs. So we need to find our average fixed costs. And we know that our total fixed cost, as given in the problem, is 1,000. If you go back and you read the whole problem, it's in the paragraph, I guess, at the beginning. And then, so average fixed costs is going to be 1,000 divided by Q. which is 1,000 divided by 20, which is 50. So our average total cost at 20 is going to be average variable cost plus average fixed cost at 20, which is 67.4 plus 50 equals 117.4, or C. 18 says if they produce 12 units of output, what is the estimated short-run marginal cost? So we have our average variable cost from the regression output, and we've used it multiple times at this point. So it's 43.4 minus 2.80 Q plus 0.20 Q squared. Total variable cost, we're just multiplying our average variable cost by Q. So we're going to get 43.4 Q minus 2.8 Q squared plus 0.20 Q to the third. So our short run marginal cost is we're taking the derivative of total variable cost with respect to Q. So we're going to get 43.4 minus 5.6 Q plus 0.6 Q squared. And then we're going to substitute 12 in for Q. So short run marginal cost 12 gives us 43.4 minus 5.6 times 12 plus 0.6 times 12 squared equals 62.60, or D. Next one, moving away from that regression output, says for the short run cost function, average variable cost equals A plus BQ plus CQ squared. Our answer is B. And this is because C being greater than 0 in front of our Q squared makes it look like a smiley face when it's positive. If it's negative, then it looks like a frowny face. And A being greater than 0 keeps your intercept, your y-intercept, positive. (20) says when estimating a cubic short-run production function using linear regression analysis, you must transform the equation into linear form by defining L3 and L2 as L cubed and L squared respectively. This is true. This is in the notes. Suppress the intercept term, regress through the origin. So this means that there's no intercept in Q equals. Which is also true. And C says convert the right-hand side variables into logarithms. That's not something that you have to do. So our answer is D, both A and B. 21 says, suppose the firm employs 12 units of capital. This is telling us that K is going to be equal to 12. At how many units of labor will marginal product of labor begin to diminish? So we're first going to substitute 12 into our original equation. So we're given that Q equals negative 0.0075 K to the third L to the third plus 12 K squared L squared. So negative 0.0075 12 to the third L to the third plus 12 times 12 squared L squared. So we get Q equals negative 12.96 L to the third plus 1728 L squared. And then we're going to use our marginal product of labor formula. So we're taking the derivative, the partial derivative of this output, and we are going to get negative 38.88 L squared plus 3,456 L. And then you're going to find the maximum of that. So we're going to take the number in front of the L. So 3,456 divided by 2 times the number in front of L squared, which is 38.88, which gives us 44.44. So if you were to sketch this at 44.44 units of, so this is the same question that we were just looking at. So we're going to start with our Q equals negative 12.96 L to the third plus 1728 L squared. And then we're going to substitute in our 10 units of labor. So we're going to have Q equals, at 10, negative 12.96 times 10 to the third plus 1728 times 10 squared, which is going to give us 159,840. And then our average product of labor is going to be the quantity divided by L. So we're going to have 159,840 divided by 10, which gives us 15,984. Or D. 23 has an average variable cost function of 88 minus 0.026 Q plus 0.000003 Q squared. So our average variable cost is this function. So I'm just going to write it down. And then it wants us to find its minimum value. So to find the minimum value, we're going to take the number in front of the Q with no exponents. And it's going to be negative 0.026 over 2 times the number in front of the Q squared. So 0.000003, which gives us 4,333.33. And then you're going to substitute that back in for our Q into our average variable cost function. So our average variable cost function at this value, so at 4,333.33, gives us 31.67, or B. 24 says if they produce 6,000 units of output and they face a total fixed costs of 300,000, what is the estimated short-run marginal cost? So we know that our average variable cost function is given as 88 minus 0.026 Q plus 0.000003 Q squared. So our total variable cost is we're just multiplying that average variable cost by Q. So 88 Q minus 0.026 Q squared plus 0.00003 Q to the third. So our short run marginal cost is going to be taking the derivative of that or substituting them in. It's up to you. And we're going to have 88 minus 0.052 Q plus 0.00009 Q squared. And then you're going to substitute 6,000 into that. So our short run marginal cost at 6,000 is 88 minus 0.052 times 6,000, just forgot a zero, plus 0.00009, 6,000 squared, which gives us 100. $25. We're using our average variable cost at 2,000 units. So our average variable cost at 2,000, we're going to substitute 2,000 in for Q. It's going to be 88 minus 0.026 times 2,000 plus 0.00003 times 2,000 squared, which gives us 48. So then we know that our average variable cost at 2,000 is equal to 48. And from the previous one, we know that it is decreasing because it is, if you come back here to our, this is our minimum, right, was what we found on question 23. So it's falling because it's greater than the max, or greater than the min, sorry. And then we have to decide if it's greater than our short run marginal cost or less than our short run marginal cost. So if we substitute, or we find our short run marginal cost, we're going to have 88 minus 0.052 Q plus 0.000009 Q squared. And again, we're going to plug in our 2,000 units for that. And when we do that, we get 20. So 48 is greater than 20, which means C is true. So our answer is both B and C. $26, we have our short run marginal cost function is defined as 96 minus 4Q plus 0.15 Q squared. So our total variable cost is going to be 96 Q minus minus 2Q plus 0.05 Q to the third. And then our average variable cost is going to be 96 minus 2Q plus 0.05 q squared. So from this to this, you can either undo the formula, which is an option, or if you have a strong calc background, you are more than welcome to you're essentially undoing the derivative and seeing what happens. From our total variable cost to our average variable cost, we are dividing by q. So it's getting rid of the q after the 96, and then getting rid of the exponent on our 2q squared, and then subtracting 1 from our exponent on our q to the third, or our q cubed, which gives us an answer of E.